So round of applause for the first talk, Rashmi, and the slides are here. You can use the clicker if you want.
I don't. Okay. So, right. Okay. Hi, thanks. Hi everyone. I'm Rashmi, and I'm a software engineer based in India. So my talk title is Go for the JavaScript developers. So let's get started. Go is like the C and the Python has a kid. So it's a common saying that Go possesses the confidence and the athletic ability like a C, and it has the good looks and the pleasant demeanor like a Python. So what exactly is Go? It's an open source compile and garbage collected concurrent system programming language which is blazing fast because it has a young compiler with minimal speed optimization, and also it has a strict compiler, and so it's something like the things like unused imports and the unused variables or hard compile errors in Go. And it possesses clean and elegant syntax. So what are the similarities between the Go and the JavaScript? So both uses the garbage collection, and the variables and the functions, they have a specific scope. And in similar fashions, they define the variable structures and for loops and the if statements. What are the major differences between the Go and the JavaScript? So JavaScript is a single-threaded that it has the main thread which does this event loop, and there are several other threads which do the external input-output. While in the Go, the concurrence is the king in the sense that it has the Goroutines. And the JavaScript is interpreted language. It runs before the code is compiled before it runs, while Go is a compiled language. And also in Go, we can have multiple return statements. That is, if you have, let's say, an error called 500 internal server error or something like that, particular functions can return the multiple error codes. So it's very consistent and it's easy to maintain. So basic rules that the lines don't end with a semicolon, and so it's a very simple example is declaration of the array of size 3, which has integer values 1, 2, and 3, and there is a comma at the end of the 3. And the basic types like var num int is equal to 5. So it says that the variable name, that is num, it's being declared before the integer, the data type itself. So in similar fashion, the for loop and the while loops, the similarity which we can see in those of them is that they don't have the parentheses. And in the same way, the flow control, that is, there is no parentheses in the if statement. It returns false when the age is less than 18 or. So what are so there are some of the advanced features in Go, that are the Go routines, which I already talked before. That concurrency is the king in the Go, which so the Go routine is basically a lightweight thread which is managed by the Go runtime. And so here Go the function and the ABC are the 3 parameters. So what happens is the function and the evaluation of the ABC will happen in the same thread itself, while the function will the function will be executed in the different thread. And the channels, they can be thought of as the pipelines or the pipes like in which the Go routines themselves communicate. And they also possess a type associated with it, that is the data which is allowed to transport through that particular channel. And it's being declared using this operator, that is a channel operator. Here we can see in an example that channel V. So V is being sent to the channel CH, and similar way, and how we are assigning the value to the V is, that channel receive the value from that particular channel and assign it to the variable that is V. Okay, and the personal takeaway is that those who have not yet started with the Go, it's never too late to start something anew, afresh. All it takes is practice, patience, and perseverance. I really want to thank Carolyn, Rita, and Mathice for helping me, getting introduced to the Go language, and thank you for inspiring me a lot. That's it.
Okay, so up next, Tomasz. Round of applause for him too, please.
Okay, so hello, I'm Tomasz, and today I will show you my debugging adventure with Golang. So one evening, my colleague was deploying a service on our infrastructure, And what happened? This service was not appear in our production. It was deployed, but it wasn't attached to a load balancer and console, which was our discovery solution. So I asked him, hey, try deploy it one more time, but obviously it doesn't help. And so we started debugging, like what could be a problem. At that time, our infrastructure was built on Marathon, which is our application scheduler, console, discovery solution, Marathon console, which ties application deployed on Marathon to console, and the service that was deployed. So we had like 300 services, and only one has a problem. So what has happened? This application has exposed 2 ports, one for admin and one for the rest of the world. Each port has a tags, and both ports were registered with the same tags. So because it was tagged with has the same tags, one port disappeared from console. So what has changed? Because this service was deployed many times a day, one tag has been appended. So at the time we have 80% of our application has only one port, 8% has tags, and only one that fails has multiple tagged port. So let's take a look at code, and here's a bug, like something here. So what happened? We just add one tag, and we end up with 2 same slices. I will unroll this for loop for you. So it looks like this. And you can guess what function A and function B prints. Like, I haven't been expecting this at the time. So what happened? Yeah, slices. What is slice? Slice is just 3 elements, like a pointer to a array, length, and capacity. And when we append it to a slice, and it has sufficient capacity, we only change the last element and update the length. So in our example, it looks like this. We start with a slice like this, then append element, then append next element, and next element, finish with 3 variables pointing to the same space in a disk, in a heap. So yeah, when we run this and print memory locations, we see that everything is in one place. Yeah, and in our second example, like these pointers are different. So yeah, I was expecting slices to work like this every time. Unfortunately, they do not work like this. So be careful when using append. Do not append to slice when you want to keep unchanged. Yeah, and remember, you are never working on a copy of your data. Okay, thank you.
Quick question, how many of you have been beaten by this? Yeah, okay, good. Same. Okay, so next up we have Jaana. And round of applause for her.
Hello. This is my 8th year at FOSDEM, 5th at Go Devrooms at FOSDEM. So it's been a wild ride, and I have no intention to speak here, but I saw this room and I was like, this is legit. I should at least give a lightning talk. So these are some like style tips I have for Go packages because I signed up to be a Go readability reviewer for a long time at Google, and like some of this stuff is really obvious, but it comes very often. So first of all, if you need any style guideline tips, feel free to reach out to Golang Knots or the Go for Slag. You should also check out the code review comments. This is just like general tips, and this entire presentation is also available as an article on recul.org style-packages. So the first thing is about organization, because organization is what matters. You try to use multiple files. Go allows you to split your package in multiple files, and you can just create some logical separation. For example, this is the HTTP package, and you can put all the header related stuff in headers.go, cookies related stuff in cookies.go, all the core stuff maybe in http.go, or maybe it will get too long and you can split it as client.go and server.go. Try to use multiple files. The other thing is keep types closed. For example, the core header type can maybe fit better in the headers file because all the other methods and other functionality, maybe some utilities will go there. Some people usually make the mistake of putting headers type into the http.go file or at the initial enter point of the HTTP package because they think that this is a core type. But try to put it in where it makes sense because you want to be able to jump back to the type and see and use it as a reference. It kind of helps you with when you're reading the source code. The other thing is organized by responsibility. I came from C and then later Java, and I had this especially because of the Java background, I had this habit of creating, for example, a models package. I would put all my entities there. In Go, we don't do this. We instead put everything by responsibility in their respective packages. For example, if you have users, that's cool. If you have a user service type of package or a management package, put the user entity there because this is where you will also put functionality to return you users and that type of stuff. Provide examples in Go docs. This is really actually cool because Go allows you to embed snippets in the Go doc, and especially if the usage is not trivial, this is kind of like giving your users a way to copy paste and quickly just get an understanding of how to make a call to the function. And there's a really good blog post actually on the Go blog about this. Go doc examples are testable, so you write them as test functions, and they are run as a part of Go test. So they're compiled, tested, and they are never get an absolute because they're a part of the Go test. I would say that try to optimize for Godoc because this is something when you're designing the API initially, try to take a look at what is going on the Go doc. I'm not suggesting that you organize entirely, but try to have a sense of how it will be represented. Because Go doc will be the entry point of your users. And I said Go space doc because Frances told me that it's the other stuff is deprecated. But Go space doc HTTP will be only available in 1.11, so you better try to take a look at the current alpha, whatever the official name, because there's no RC. But either use Go doc or wait for 1.12. Anyways. Put binaries in commands. This is very common. All the main functions should go into /command. This is the Go tool in the Go core repository. I will talk about some naming stuff. Lowercase stuff only. No camel case. No underscore. Short but representative names. No common. No util. If you want to use util, use some context, say HTTP util. Try to enforce vanity URLs. If you have this fancy URLs, you can enforce them. And write some docs, please. Document the page. You don't have any excuses. And use .go if you have very long documentation so people can just, jump to that file and read as a maintenance release. And that's all. Take a look at these links.
Okay, good. Okay, and up next we have Go performance tuning. Cool. And a round of applause for him. Whatever his name is. Oh, yeah, say your name.
Oh, sure. Hi, I'm Richie. I'm a developer on Uber's open source metrics stack, M3, which is all written in Go. This is originally a 30-minute talk, so I'm going to speak very quickly. I cut out a bunch of stuff, but it's basically a war story from production. So basically, Uber has this service called the ingesters. And their job is basically to just receive metrics at like regular intervals and then write them to storage as quickly as possible. So one day we deployed our ingester service, kind of like routine deployment, because they hadn't been deployed in a few months. And you can see that the end-to-end latency before we deployed it was like 10 seconds, and after we deployed was over 20 seconds. So this is really bad because it means graphs don't load as quickly and alerts can't catch issues as quickly. So you want to keep this P99 latency low. So we tried to figure out what went wrong, and that was really tricky because this code was in a monorepo. So we were like hundreds and hundreds of commits, and we hadn't deployed in months. So we weren't sure which one affected it. So long story short, we did a git byset in production, which is terrible. But we found the issue. And it was this. I don't have time to delve into the details, but basically the code on the right is almost the same as the code on the left. It's just code that was inline got moved into a helper function. We're like, okay, that shouldn't make it that much slower. Like calling functions isn't free, but it's not that expensive. It shouldn't make things twice as slow. So we were trying to figure out what was going on. We ran a bunch of micro benchmarks that showed no performance difference between these two versions of the clone function. So sometimes micro benchmarks lie, but we took flame graphs of both services running in production. And again, it looked like the service was spending the same amount of time in both versions of the code, so we were really confused. Kind of out of desperation, because when CPU profiles don't work, I kind of lose my mind, we SCP'd the binaries down and ran Go tool object dump on them to get the assembly. And long story short, assembly is almost the same. The only thing we noticed, though, is that the clone bytes, which is like the helper method I was talking about earlier, ends up not actually getting inlined, which got us thinking, and we went back and looked at the CPU profiles. Turns out CPU profiles don't lie. Humans just make mistakes. And there actually was a pretty big difference in this one function called runtime.morestack. But we're like, oh, that's a runtime function. Runtime's always correct. Like, can't be my fault. Turns out that wasn't true. So we dug into this, tried to figure out what this function does. And it turns out in Go, every Go routine starts with a 2 kilobyte stack. And then when you call a function, the runtime checks if you have enough room left on the stack to call the function. If you don't, allocates a new stack, twice as big, copies all the stack frames, and then resumes execution. So our new theory was that in production, our call stack was so deep, and we were right on the edge, that when you called clone, it would push you over the edge, and you'd allocate like a 4 or 8 kilobyte stack, which is expensive. And in the benchmarks, the stack was really shallow, so you wouldn't do that thing. So we're like, okay, let's try this out. Basically, in our ingester service, all the code gets executed in this worker pool. Pretty standard, basically allocate a Go routine for every piece of work. So to test this out, we wrote a new one where you allocate all the Go routines up front, you never let them die. They kind of hang around in the background, and then you assign them work via channels instead of spawning them constantly. And then you pay the stack growth cost once, right? And then you never have to pay it again. So we rolled this out to production. And the code on the left, or the arrow on the left is showing us rolling back the regression, so you see the latency comes down. The arrow on the right, though, is when we released the worker pool, so it actually got even faster than it was before. So it was like, okay, cool, we actually made this faster than it ever was originally, which is great, but we were like, we haven't really proved anything. Like, this is all kind of like incidental, like, couldn't send someone to prison over this, right? So we're like, okay, let's just fork the Go compiler and figure out, and add some print statements, because that's how we debug everything, and see if this is actually happening. So we forked the Go compiler, added some sampling so that we wouldn't be printing millions of logs, compiled our service with the forked Go compiler, threw it up into production again because that was the only place where this issue would manifest. It wouldn't show up in staging. Immediately started seeing logs like this where it's saying, okay, like around the clone bytes function, I just had to grow the stack from 4 kilobytes to 8 kilobytes. So if you put an 8 kilobyte allocation in the hop path of your code, that could definitely explain why it gets twice as slow. And then we just basically counted the number of print statements, and we saw that with the regression, there were a lot, and with the new worker pool, there was none. Okay, thank you. Thank you.
No, you. Okay, so up next we have... People need to put their names. McCabe, John. Oh, John. Okay, cool. So up next we have John. So round of applause for John.
Hi. So this is going to be a little bit lighter than that sort of technical deep dive that we just had. And it's a little tool, it's a little sort of package I wrote myself to sort of scratch an itch that I had, where I was finding myself constantly sort of running commands to check the status of things that I just wanted to keep an eye on. And I thought it'd be far better keeping them up in the menu bar. So I ended up writing a package to help me generate plugins for Bitbar. So Bitbar is an application written by Matt Ryer that runs on OS X that sort of handles the rendering of menu bar applications and has like a super simple interface. You literally just have to drop in an executable that outputs text. It can be any language, it can be shell scripts, absolutely anything. And then you can control how frequently that refreshes just by appending a suffix to the file, so like .30 seconds, .1 minute, and so on. So I created a package called Go Bitbar after having originally written stuff using templates, and it was all very hand-rolled, very difficult to sort of explain to somebody how to use. And like, as I said, the main reason is that you can put pieces of information that you want up in your menu bar, so they're very quick to get to. If you've commands that you're constantly executing and you just would like to get access to, you can just pop them up there. And because you're writing it, it's completely customizable, and you can write it in Go, which is good. So using the package, this is what an absolute minimal menu bar app would look like. So you create an instance of the app with the Bitbar new. You create a status line entry. So the status line is what appears in the menu bar. So you can actually add a second one. You can just sort of invoke that status line method a second time, and it'll rotate between the two pieces of information. And then you can add submenus, and you can nest submenus, so you can have like multiple trees dropping off one another. And within a menu, you add a line, and you can add multiple lines. And then you just finally call render, and that's what you end up with there. You end up with your hello and your world. So that's a really simple example. Some of the kind of more complicated ones that I ended up putting together were for a project I contribute to, OpenFAS. I wrote a menu bar app that lets you sort of look at your OpenFAS gateways and sort of see the status of all your functions and look at your Prometheus metrics just from the menu bar, which was kind of useful when you're developing and you maybe have left something running, or you just want to kind of at a glance check what's going on. So you can see there the submenu, and you've got actions. So if you click on the action, that's actually going to go and invoke a command that deletes a function. Open the gateway, open Prometheus, they'll open Chrome and open browser. So you can do pretty complicated things without having to write a huge amount yourself. So like, for example, to add a link to URL, you just add a line, so give the line a bit of text, and then you use this href. It uses a builder pattern to build things up. The href just takes the URL. So in this case, it's an SSH URL, and it's just using OS X's open, so that'll just open a terminal, and the terminal is true so that it actually doesn't suppress the terminal. But that could be a URL, it could be HTTP, HTTPS, whatever. If you want to execute a command, so you can execute any arbitrary command, but if you want to actually build some functionality into your plugin, what you can do is you can use Cobra, that like Caroline showed earlier on, and you can add extra subcommands. So in this case, I added a delete subcommand that in the rendering of your menu, it knows the host name in the context, and you basically, it just calls the plugin again with delete and the name of the host name. The terminal is false because that stops the terminal popping up, so it just goes ahead and deletes it, and you don't see a terminal pop up. And the refresh true automatically refreshes the menu bar, so you get the latest information. So some other ones, this is I'm very, very lazy, and opening a browser is too much work. I have a menu bar app that shows a traffic camera from my trip home. So. Some links. So Matt Ryer's Bitbar app is on Get Bitbar. I'm always surprised at the number of people who haven't actually heard of that. It's really, really awesome. And there's a link to the package for building your own plugin. So, thank you.
Awesome, thank you. Okay, and last but not least, Ron Evans, and I'm going to give you a little bit more than 2 minutes. You have like maybe 5 minutes because we have the room to close, and I know that yours is complicated. Yes. You do you. This.
In theory, it all works. practice, it sometimes works. I see something. This is good.
So the demo is setting up projector with Linux.
The smarter, the more intelligent the speaker, the more AV problems. I have no AV problems, so...
Yeah. Oh, you ready?
I'm ready.
Cool. Round of applause for Ron.
Hey, everybody. Before I get started, I just want to say, let's give up a big round of applause for Francesc and for Margie. They have done an amazing job organizing this. Come on, give it up for them. There were others, but I can't pronounce their names. I'm really sorry. I could barely pronounce yours. All right, so I am Dead Program, Ron Evans in the real world, Dead Program on all the internets. I run a small consultancy called the Hybrid Group. We do software for hardware companies, and I really like robots. But you probably know that. You may have seen me talk about GoBot, which is Go programming for middleware for robotics, or GoCV, which is computer vision in Go using OpenCV. But today I'm here to talk about a really cool new project that I've been collaborating with my colleague called TinyGo. So it's a Go for small places, really small. We mean like microcontrollers. In other words, devices that have between 8K and 32K of RAM. I did not say megabytes, I said K, 1,000, small, right? Or WebAssembly, but you know, we'll get to that in some other future time. So everyone says Go is too big. Right? Everyone says Go is just too big. Well, a gopher is a gopher, no matter how small. Actually, Dave Cheney did not say that, but doesn't that sound like something he would say? So, thank you, Dave. Dr. Dave. So, I'm going to show you right now that Go can be tiny. Yes, it is true. I am going to show you, and I'm going to show you with this. Let me put the mic down for a second. Hopefully not. Even though I appreciate that, I might.
It's always a pleasure.
We shall see. So first I'm going to run a GoCV program, so I've got my camera. Hello, okay. And so now I'm going to show you the microcontroller I'm going to use, which is this itsy bitsy, literally itsy bitsy M0. It's made by Adafruit. It is a really cool little board. I kind of almost do need two hands. 3, whatever. More. All right, so the Itsy Bitsy is a microchip, the company that bought Atmel SAM-D21. It's an ARM Cortex M0. It's a 32-bit processor, 48 megahertz speed, and 256K of flash memory. 256K. All right, so let's do this. The Hello World of Things using TinyGo is a very simple little Go program, package main. We import machine, which is our package from TinyGo, how we integrate with the actual hardware devices. The time package, you've seen that before. And then our first thing we're going to do is say LED equals machine.gpio machine.led. So we're saying this particular machine's LED. We're going to configure it to be a GPIO output. That means we're going to send something out versus receive a signal in. And then forever, first we're going to set it to low, in other words, turn it off. We're going to sleep for 500 milliseconds, then we're going to turn it on, and then sleep for another 500 milliseconds. So it's the hello world of things as a blinky light. So let's see if this works. First, I'm going to plug it in. It's plugged in. I'm trying to talk into the microcontroller. Next demo. Next demo. One. Okay, so the first thing I'm going to do is I'm going to press the little button on this twice to put it into the bootloader mode so I can load new software. I can't show the camera. That's kind of cute. I should do that on purpose. Haha. So we're going to load this code by compiling it first. Okay, so we just compiled a bin file. So let's look at how big that bin file is real quick. So we can say that is 2,376 bytes in size, okay, that program. So let's put it on here. So we're just going to convert it into a hex file, which then is going to convert it into the UF2 bootloader format. So it just copies it on there, and now if we go to the camera, we can see it is blinking. Yes, it is real. How can you do that? Isn't that impossible? Well, luckily the Go compiler toolchain itself is written in Go. And then there's this other thing called the LLVM, which is an actual toolkit for building compilers. So if we put those things together, we can use Go's front end to put it into SSA form, then use TinyGo's compiler to turn that into the intermediate representation that LLVM uses, and then use LLVM to generate binary code. So it's a different way. It's a different gospel of the Go compiler, if you will. So you want to know more? tinygo.org. We have a great website that has been put together by the founder of this project, Ike, who's actually in the back of the room, kind of embarrassed right now, and a bunch of other collaborators. Also, come see my talk tomorrow, Building K, that's the big building in La Fontaine, 11 a.m. You should be there. Why? Because, first of all, it's the first ever FOSDEM main room talk about Go. Isn't that incredible? And it's a very small Go. So there will be prizes, thanks to Adafruit and others. So if you show up, you can maybe win something. So definitely don't miss it. Main room, Building K, La Fontaine, 11 a.m. Be there, be there, be there. Also, the very first ever TinyGo BOF will also be tomorrow at 1300 hours. So after we've all kind of calmed down from the drones flying around and stuff, we can talk about all this. So thank you very much.
And with this, I'm out. With this, we're done. So thank you very much, everyone, for coming. Special thanks to all of the speakers. Without you, this would not be possible. And what? Oh, yeah. So we are all grown-ups and responsible. So if you brought some trash, take it out with you. If you didn't bring any trash, but there's some around you, take it out with you. And if you're interested in seeing me suffer tomorrow, I'm seeing a whole day. I will be at the ML on Code room, so I'll be there. See you tomorrow.